The second question is the probability density function of a continuous random variable x is given by p of x is equal to. See here we can see there are three different intervals and they have given three different functions. Just we have to find here what k value. Apart from these three intervals, it is 0. The function p of x value is 0 elsewhere. Any interval. For example, if you take 6 to 7, this interval. If you take minus 3 to 0, all values will be what? P of x will be 0 here. That's the meaning of elsewhere here. Only for these intervals, the function is defined. Now, we have integration of p of x dx equals to 1 between the limits minus infinity to plus infinity. Now, whatever the available things in the problem, we have 0 to 2. So write 0 to 2 p of x dx plus next interval is 2 to 4 p of x dx. Next interval is 4 to 6 p of x dx equals to 1. I don't worry about any other intervals because it is 0 elsewhere. Elsewhere means any interval other than this will be 0. Now substitute the functions one by one in this integral. In 0 to 2, what is the function defined here? Kx. So write that kx here. And in 2 to 4, what is the function defined here? 2k. So write 2k plus 4 to 6. In 4 to 6 interval, the function is 6k minus kx into dx equals to 1. Here we need to find k value. To find k value, so we use this condition. If you remember in a discrete probability distribution, to find the value of k, we used this condition. Summation p of x is equal to 1. We added all the probabilities and equal to 1, then we could find k value in discrete. But here we have to do integration to find k value. Now, here k is constant, keep as it is. X integration is x square by 2, 0 to 2 plus 2k is constant. Constant integration is constant into x. So limits 2 to 4 plus 6k is there. 6k is constant. So constant integration is constant into x minus k into x integration is x square by 2. So limits 4 to 6 equals to 1. Now k constant by 2 constant. Now put the limits 2 square minus 0 square plus 2k into upper limit 4 lower limit 2 plus 6k into upper limit 6 lower limit 4 k by 2 upper limit 6 square lower limit is 4 square equals to 1. 2 square is 4, 4 minus 0, 4, 4k by 2. 4 minus 2, 2, 2 into 2k, 4k. 6 minus 2, 6 minus 4, 2, 2 into 6, 12k. Minus k by 2, 6 square is 36, 36 minus 16, we get 20, 20k equals to 1. Here 2 times 2. So we get 2k plus 4k plus 12k minus here 2 times 10. Here k is not required, k is already written. So 10k we get here equals to 1. So 2 plus 4, 6, 6 plus 12, 18, 18 minus 10, 18. Sorry, 2 plus 4, 6, 6 plus 12, 18, 18 minus 10 is 8k. 8k is equal to 1. So k is equal to 1 by 8. So that's your value here. So if the problem is given with multiple functions and multiple intervals, this is the way how to split and then find the value of k by equating to 1. This is one question. Next. Find k such that f of x is equal to kx e power minus x is a PDF. and also find the mean. First you have to find k value. So to find k, we have integral minus infinity to plus infinity f of x dx equals to 1. Here we have big interval minus infinity plus infinity. But here in the problem we have only one interval 0 to 1. Just copy that 0 to 1. F of x dx is equal to 1. For all other intervals it is 0. Otherwise it is 0. Therefore we don't worry about any other intervals apart from 0 to 1. Now substitute 0 to 1 f of x here kx e power minus x dx equals to 1. K is constant, take it outside the interval. 0 to 1 x e power minus x dx is equal to 1. Now we have to apply product rule for this integral. Because we have two functions x and e power minus x, we have to apply product rule. Or we have another rule called Bernoulli's rule. It's very useful for doing integration by parts. U into v dx. If u is a polynomial and v is exponential, here we can see this is u and this is v. Okay, first function is u, second function is v. If you have this kind of polynomial and exponential merged together, you can directly integrate using the formula first function u into v1 integration minus u dash v2 plus u double dash v3 minus u triple dash v4 plus etc. Like this you have to do integration. Here dash, double dash, triple dash means differentiation. Dashes, differentiation. Here suffixes, you can see suffixes 1, 2, 3, that is integration. v1 means one time integration, v2 means double integration, v3 means triple integration. Dash means one time differentiation, double dash means two time differentiation, triple dash means three time differentiation. So we have to apply the same rule here. K into first function is x, keep as it is. v1 means what? E power minus x integration. So e power minus x by minus 1. We have to divide by x coefficient when you do integration. Here minus 1 we have. Minus u dash. What is u dash here? X differentiation is what? 1. v2 means this is integrated once again. E power minus x by minus 1 whole square plus u double dash. U double dash means one differentiation is 0. It ends here. If you do any times differentiation, it will be 0 itself. It ends here. 0 to 1 equals to 1. So that's the benefit of Bernoulli rule. At some stage, the series will be vanished. It becomes 0. See here we got 0 means then you do any number of time integrations, it is 0 only. Next we have to substitute the limits. Here we have minus x e power minus x minus 1 whole square is plus 1. How did we get here minus 1 whole square? Because already we have minus 1 in the previous step. After integration this, we get one more minus 1. So minus 1 into minus 1 is minus 1 whole square. And then here e power minus x is equal to 1. You can take minus outside here to make it easy. Minus k into x e power minus x plus e power minus x is equal to 1. Limits 0 to 1. Still you have to put limits here. Upper limit, lower limit. Upper limit is 1. You put 1 here. 1 into e power minus 1 plus e power minus 1 minus of lower limit. X is equal to 0 means it will be 0 plus e power 0 equals to 1. So minus k into e power minus 1 plus e power minus 1 is 2 e power minus 1. Like terms, right? And here e power 0 is 1 minus 0 plus 1 is 1 equals to 1. We want k here. K into e power minus 1 can be written as 2 into 1 by e. When you take this to the denominator, the power sign changes. Minus 1 equals to 1. E LCM, we get 2 minus E equals to 1. Therefore, K is equal to, just send this term to RHS, it becomes E by 2 minus E. This is the K value. So your integration is very important. We have to make use of Bernoulli rule to make integration easier. We are going to use Bernoulli rule once again now in the same problem because we need to find mean also here. Mean is asked. You have to find your what? Mean value. Okay. First step is over, finding K. Next we have to find your mean value. Mean is given by mu is equal to integration minus infinity plus infinity x into f of x dx. This is the mean. And here we have interval highest is 0 to 1 x f of x dx. And interval 0 to 1, the function defined to be kx e power minus x dx. Take that k outside. X into x, x square e power minus x dx. Now we have to apply again Bernoulli rule. This is u and this is v. Right? So again I'll write here, Bernoulli rule means what? uv dx is equal to uv1, u dash v2, u double dash v3 minus u triple dash v4, etc. This is Bernoulli rule for doing integration easily. Now apply the same rule here, k times uv1 means u is x square k as it is. v1 means integration of e power minus x is e power minus x by minus 1 minus u dash. U dash means x square differentiation 2x into v2 means integration of this once again e power minus x. We get one more minus 1, it becomes whole square plus u double dash means what? 2x differentiation, once again 2, and then e power minus x by again minus 1 whole cube. If you continue, u triple means what? 2 differentiation is 0. So all the terms will be 0 later. The limits are here 0 to 1. So here k into, now minus goes to numerator, minus x square e power minus x. Negative square is positive only, here minus 2x e power minus x. Here negative whole cube is negative only, so minus 2 e power minus x. Limits 0 to 1. Now you have to put limits. Upper limit is 1. In place of x you put 1. You get e power minus 1 minus 2 into 1 into e power minus 1 minus 2 e power minus 1. This is upper limit. Minus lower limit. Lower limit 0. In place of x 0 means this will become 0 and this becomes 0. And here 2 into e power 0 you get. Here all these three are like terms. Minus e power minus 1, minus 2 e power minus 1, minus 2 e power minus 1. It will be 5 e power minus 1. And then here minus of minus 2. Right? E power 0 is 1. So minus 2 into 1 is 2 equals to k times minus 5. E power minus 1 can be written as 1 by e minus 2 minus plus 2. This equals k into minus 5 by e plus 2. And what is the value of k here? From the previous step we got k value e by 2 minus e. So write that e by 2 minus e into, here e is common, take common, LCM, and we get here minus 5 plus 2e. So e cancel here, we'll get 2e minus 5 by 2 minus e. So this is your mean value. So in this problem, integration plays very important role. That too we have to use a Bernoulli rule for doing integrating by parts. So this is also one of the important question. And I didn't ask to find your variance. just mean is asked in the problem. So we stop it here. Thank you.